All right, let's see how we can implement bucket sort. This one is a little bit tricky, but I'm going to make it super simple for you. How can we create a linked list in Java? We talked about this in the first part of this series. We have an interface called list. This is a generic interface, which means it takes a generic argument. And with this argument, we specify the type of each object in this linked list. Here we want a linked list of integers, so we write list of integer. Now let's import this interface. All right, so let's call this X, and here we set this to a new array list. So to refresh your memory, list is an interface, and array list is an implementation of this interface. If you're not familiar with this concept, you really need to watch the second part of my Ultimate Java series, which is all about object-oriented programming. There, I talked about this in detail. So list is an interface, and ArrayList is a class that implements that interface, okay? Now, let's talk about our buckets array or buckets list. Each object in our buckets list should be a linked list of integers. So to create our buckets, we write code like this: list of integer. So we have a linked list, and every object in this linked list is a linked list of integers, okay? We call it buckets, and once again, we set it to a new array list. Now we don't need the first line anymore. Okay, now we need to iterate over our input array and distribute items to various buckets. So for each item in our input array, we go to our buckets, but which bucket? Well, as I told you before, we need to get this item and divide it by the number of buckets. Now, how many buckets do we need here? We don't want to hard code that as a value like 3. We want to have the flexibility to pass the number of buckets from the outside. So here we add a parameter, integer number of buckets. We allow the client of this class, whoever is using this class, to pass the number of buckets. That's a flexible implementation. So here we have our buckets linked list. With linked lists, we don't have square brackets. We use this only for arrays. So here we use the get method, and this will return the object or the bucket at a given index. So we get item and divide it by number of buckets. Now each bucket is a linked list of integer. So if you use the dot operator, we can see the methods of linked lists. Here we're going to use the add method to add the current item in this bucket, okay? Now there is a tiny issue in our implementation. If we run this code, we're going to get a null pointer exception, because here we're trying to get the bucket at a given index, but this bucket doesn't exist. So here we create a list of buckets, but this list is initially empty. So we need to initialize this list with empty buckets. How do we do that? Super easy. We need a for loop. For I, we set it to 0. As long as it's less than the number of buckets, we increment I. Here we call buckets.add. What should we add here? Well, we expect a list of integers. So here we pass a new array list. Once again, every object, every item in this buckets list is a list of integer. So here we're setting each object to a new instance of array list. All right, we're done with distributing items into various buckets. Now we need to iterate over our buckets and refill our input array. That is super easy. So for each bucket in our buckets, first we need to sort that bucket. We can use one of our sorting classes, or we can use the quick sort method in Java. So here we have a class called collections. This is declared in java.util package. It has a static method called sort. This is the implementation of quick sort. And this method, as you can see, takes a list of integer. So we can pass any object that implements this interface. So here we pass our bucket. This will sort our bucket. Then we need to iterate over every item in this bucket and insert it into our input array. So for each item in this bucket, we need to go to our input array. Now here we need a counter. So let's declare that over here. We set I to 0. Now we use I as an index and set it to this item. And of course, we should increment I. So next time we store the next value in the next element. So this is the implementation of bucket sort. Now we can refactor this code and make it cleaner by extracting these few lines into a separate method for creating buckets. So let's declare a private method. a private method that returns a list of integers. We call it create buckets and give it the number of buckets as a parameter. So number of buckets. Okay. Now I'm going to go in our public method and select these few lines, cut, paste them over here. And of course, we need our input array over here. So let's add that as a parameter, integer array. Okay. Now, finally, in this method, we return our buckets. That is better. Now, this method has only a few lines of code, and it has a single responsibility, creating buckets. So in our public method, we can simply call this. We can set buckets to create buckets, give it our input array and the number of buckets. Now, in fact, we don't even need this variable because we have used it in a single place. So we can replace that with a call to our create buckets method like this. Take a look. So we create the buckets over here. Then we go to each bucket, we sort each bucket, and finally insert the items into our input array. As simple as that. Now let's test our implementation. So back in the main class, I'm going to replace counting sort with bucket sort. And let's pass 3 as the number of buckets. There you go. Our array is sorted. What if we have 2 items? It's still working, so it doesn't matter if we have more buckets than the number of items in our input array. Now, what if you have a single item? Still good. What if you have an empty array? Perfect. So this is how we implement the bucket sort algorithm.